Section 4.7, Optimization. Please download the worksheet and follow along for example number 2. Example 2. City planners want to fence off a rectangular plot of land to make a community rose garden. The south end of the courtyard is adjacent to an existing building and does not need a fence. The west side of the plot costs $10 per linear foot to construct, and the remaining two sides cost $20 per linear foot. If the city has raised $5,000 for the fencing project, what are the dimensions of the plot that will give the community the largest garden? Here is my solution. Step 1. Understand the problem. Read it more than once if you have to. What is the unknown? Well, the unknown is the dimensions of the plot that give the largest garden. What are the given quantities and the given conditions? Well, a condition that we have is that we only have $5,000 to spend. The west side cost $10, and the other two sides cost $20 to build. Step 2 is draw a picture. So here is my south side, and the west side, and the north side, and the east side. Step 3, make some notation. So I called the north side X, and I labeled it $20 to remind myself that it cost $20 to build the X side. Y I called the west side and wrote $10 to remind myself that it costs $10 to build the west side. The dimensions of the east side are the same, so I also called the east side Y. However, on the east side I wrote $20 to remind myself it costs $20 to build on the east side. Step 4. Substitute to make a relation of one input variable. I know that the area of this rectangle is x times y, length times width. But I also know that the cost equals $5,000 because that's how much money we have to spend. And that's equal to the construction of the west plus the north plus the east. The west plus the north plus the east. And in math terms, that's $10 times y for the west, $10 times y for the west, $20 times x for the north, $20 times x for the north, and $20 times y for the east, $20 times y for the east. So now I have to find the absolute max or min. So my cost is equal to $5,000, which is equal to 30y. I simplified 10y plus 20y is 30y plus 20x plus 20x. I solved the cost equation for x. Then I substitute that into my area equation. X got substituted. This is x times y. And I'm looking for the maximum of that area. I took the derivative of the area function with respect to y and set it equal to 0. Then solve for y. And I found y to be 83.33 feet. I also need to find x. To figure out x, I just plug my value of y, 83.33, in for y and simplified to find x. I calculated x to be 120 feet. The north end of my rose garden should be 120 feet, and the west and east ends of my rose garden should be 83.33 feet.